Hello guys, how are you today? Before I start this video, I would just like to say my condolences for Prithika and Sabas Ruiz. She was a grade 8 student and she got into a car accident and she passed away. I hope her soul is resting in peace and may God grant her like a wonderful and comfortable position in the afterlife. So please guys, she's in Sabas Ruiz. If you want to send your condolences or anything nice, please do. And for all the students in Sabas Ruiz, I'm so sorry for your loss, and I really hope that you guys can continue strong. And she is one of our Sabas students, one of part of the Sabas school, and she's really a very important person. Even if we didn't know her personally, she's still an important person in our lives. So thank you for listening to this message, this short 1-minute message, and let's proceed with the video. Which statements are true about neutral objects? Whenever we're talking about neutral objects, we know that if they are neutral, they can be attracted by positive and negative charges, no matter if they are conductors or insulators. Now, how does this happen? This happens by polarization. Now I want to open a picture for you over here. This is the polarization of an atom. What happens here is that there happens a separation, okay? Or the phases switch. What scientists believe, physicists believe, is that an atom, okay, has two faces, a positive face and a negative face. So this is a neutral atom. It has a positive face and a negative face. But however, if you approach to it, let's say a negatively charged object, a negatively charged rod, it will then switch its face to the positively charged next to the negative side, and the negative to the other side. Now this polarization causes a strong attraction between these two charges that any other charge that comes from here is not gonna work effectively. Okay, so we will see an example later on in the quiz, but for now all you need to know is that neutral objects, whether conductors or insulators, if they are neutral, initially they are attracted by positive and negative charges, and if they are attracted to one, then definitely they are gonna be repelled from the other. So let's think of it like this. Okay, I'm gonna go really deep into these so it's understandable a bit. We have a ball. Okay, this ball this atom is neutrally charged, so it has two positive and two negative charges. But then if we approach to it a positively charged rod, what's gonna happen is that these negative charges are gonna be attracted to this positively charged object. So the electrons are gonna be attracted to the positively charged object. And what's gonna happen is that, theoretically, just like how I like to explain it, theoretically is that the negative electrons are gonna overpower the protons, and so then it technically makes a negative atom. So now you have a negative atom and a positively charged object. So if you are to bring a negatively charged object over here, it is gonna repel the ball. So all you need to know is this for this question, and let us answer it. Neutral conductors are attracted by positive charges. Yes, for sure, we said neutral conductors or insulators are attracted by both positive and negative charges, but one at a time, okay? They cannot be both at the same time. Moving on, we have neutral insulators are repelled. No. Neutral insulators are attracted. Yes, by positive charges. Neutral conductors are attracted to neutral insulators. Definitely not. It's either attracted to a positive charge or a negative charge. Neutral conductors are repelled by negative charges. Definitely not. So that's the first question done. Now we move on to the second question. Which statements are true about the role of charged particles in electric conduction? Now, all we need to know from this is that about semiconductors is that like when the electrons are being shared, they leave gaps behind, and these gaps is what causes the other electrons to move, which can cause a flow of electricity. In metals, we have only electrons that move, and we call these free electrons. Okay, in an insulator, the electrons are fixed in their location, so they cannot move, because how does the electricity move? So let's say this is a metal object. In this metal object, you will have many free electrons moving around. So if you bring a charge, let's say this is a positively charged, just a positive charge in general, it is gonna move through the electrons and pass all throughout this block. So everywhere you touch is gonna then become positively charged. However, if we are talking about any insulator, okay, in the insulator, the electrons are fixed. So let's say they are like here. These are the electrons, they are fixed. So if you bring a charge over here, it's gonna stay here. It's not gonna move there. You bring it here, it's gonna stay here. It's not gonna move, and it's not gonna pass throughout the whole object. So, okay, when we are talking about conductors and insulators, you should know they are moving by electrons. However, if we're talking about any liquid, especially molten, so molten, or aqueous, or electrolysis, I don't know if I spelled it correctly. I believe I didn't spell it correctly, but who cares? I'm just gonna explain for now. Ignore my spelling. So, an example of electrolysis, they try this experiment. They bring a negatively charged rod that they will call the cathode, and then a positively charged rod that they will call the anode. And then they bring anything, molten, aqueous, whatever. Okay, let's say we have something molten, so like molten NaCl. Now what's gonna happen is that the cations, the positive ions, okay, is gonna separate from the anions, which is the negative ions. And because this becomes an A+, it is gonna move to the negatively charged side, which is the cathode. And then, because these are Cl-, it's gonna move to the positively charged side, which is the anode. And what happens is separation. So these ions, we call these ions, they are moving, okay, because of electric conduction. So, all in all, let us now see. In an insulator, all electrons are fixed to specific locations. In some semiconductors, gaps left by electrons can cause conduction. In metals, only electrons move. Now here, look, a conductor allows charge to spread through the motion of positive ions. Ions only happens in electrolysis, which is molten or aqueous solutions. Now, question number 3 is a very nice question. We need to apply something called Coulomb's law. Okay, this is just in general, the law is the force is equal to quantity charge 1 times quantity charge 2 divided by the distance squared. Okay? So they told us a positive charge Q is placed between two fixed positively charged objects of Q and for Q as shown in the diagram below. The distance between Q and capital Q is 6 centimeters. So we have this distance over here, which is 6 centimeters. If the net electric force on Q is 0, the distance between Q and for Q is whatever. What does this mean? This means we have two F's. We have force 1 over here, which is the repulsion, because we have positive here, and positive here. So we have repulsion, which is force 1. This is repulsion 1, force 1. And this is repulsion 2, which is force 2. So if the net electric force is 0, that means force 1 minus force 2 is equal to 0. Why do we subtract them? Because they're going in opposite directions. If they were going in the same direction, we add them. However, if they are going in opposite directions, then we subtract them. So anyways, they told us the net electric force is 0. That means F1 is going to be equal to F2. Now, very simply, what we are going to do is we are going to find F1 and F2. To find F1, we are going to do the quantity Q multiplied by the quantity small q divided by the distance, which is 6 centimeter squared. Now, to find F2, we are going to do the quantity 4q multiplied by small q divided by the distance 2 squared. Now we said that force 1 is equal to force 2, so what we're gonna do is make them equal to each other. So the capital Q times Q divided by 6 centimeter squared, like all of it is squared, is equal to 4Q times Q divided by the distance 2 squared. Then by doing cross multiplication, what you are gonna get is the distance 2 squared times capital Q times small q is equal to 6 centimeter squared multiplied by 4 times capital Q times small q. Now what do you have the same on both sides? You have capital Q, same on both sides, and small q, same, same on both sides. So that leaves us with what? D2, the distance 2 squared, is equal to 6 centimeters squared times 4. So distance 2 squared is equal to 36 times 4. So distance 2 squared is equal to 144. That means distance 2 is equal to 12 centimeters. And that is it for question number 3. Moving on to question number 4. This is what I said in number 1, where we will go deeper into an explanation. So a neutral pith ball, neutral means it has same positive, same negative charges, is placed to the right of a positively charged Q insulated sphere, as shown below. Now what's gonna happen is, due to polarization, this is our ball, it has, let's say, positive here, negative here, and they brought this positively charged sphere. What's gonna happen is that the negative are gonna overpower the positive, okay, because it's neutral. This can either overpower this, or the positive can overpower the negative. So what happens is we bring next to it a positively charged object. So what is attracted to the positive? It is the negative. So as a result, the negative is gonna overpower the positive and initially, like not initially, theoretically kind of cancel them out. Okay? So they don't actually cancel out, but as a theory, just a way of understanding it, they cancel out. So what's gonna happen is that the pith ball is gonna move towards Q because it will become polarized. We call when one charge will overcome the other. This is in my terms of explaining, by the way. When one charge will overcome the other, then we call this polarization. So the pith ball will deflect towards the sphere because it will become polarized. Now they told us a second negatively charged insulated sphere is placed on the opposite side of a pith ball, as shown below. Now, as we said, because it got polarized, then the negative overcame the positive. So now this is a negatively charged pith ball. So what's gonna happen is that if we bring next to it a negatively charged sphere, it's gonna push it, it's gonna repel it even more, which will then attract it, which will not attract it, which will push it or deflect it more towards the positively charged sphere, which is the first sphere. So it will deflect further towards the first sphere. Okay, now we move on to question number 5. A polythene rod is rubbed against a paper sheet. Subsequently, the rod acquires a charge of magnitude 5 nanocoulomb. Take elementary charge as this. They need to find what the number of electrons. Okay, so let us think of it first of all, break it down step by step. polythene rod means definitely it's gonna gain a negative charge. So whenever we see rubbing, when you rub two things against each other, they will acquire opposite charge. So if polythene acquired negative charge, then the paper sheet will acquire a positive charge. Okay, and the equation is that the charge, which I will denote by C, charge C in coulombs, or let me just write it in full form. Charge is equal to the number of electrons multiplied by elementary charge. Okay? So by word form, it is Q charge, or not capital Q, that is for energy. A small q charge is equal to the number of electrons, positive or negative, whether it's gain or loss, okay, multiplied by the elementary charge, which is denoted by E, I think. Now, if we are going to apply this, okay, first thing we know is that polythene rod will become negatively charged, so that means it's going to gain electrons. And paper sheet, we said it's going to become positively charged, so it's going to lose electrons. So first thing we can put is gained and lost. Now, how much exactly is gained and lost? First thing you need to know, when they rub against each other, they will gain the same amount of electrons or lose the same amount of electrons. So the same amount of electrons is like shared between the both of them, but they have opposite signs. So if this one will lose electrons, that's minus electrons. But if this one is going to gain electrons, that's positive electrons. Like not positive electrons, but like a plus of electrons. So to calculate it, we have over here the charge in Q, and we have the elementary charge E. So we need to find the number of electrons, N. Very simply, you put the equation, Q is equal to plus or minus N times E. Here in this case, there's no need for plus or minus because it's between two objects. So Q is then equal to N times E. So Q, which is 5 nanocoulombs. Remember, nano means 10 to the negative 9. Okay? Coulombs. You need to change it from nanocoulombs always to coulombs, is equal to the number that we need to find times the elementary charge, which is 1.6 times 10 to the negative 19. Then making it an equation, you are going to get 5 times 10 to the negative 9 divided by 1.6 times 10 to the negative 19. And you are going to get 3.125 times 10 to the power of 10. Not an option, so we're just going to choose this. So both of them will gain and lose the same number of electrons. Now we move on to question number 6. When a perspex rod is rubbed by a wooden cloth, the rod acquires a negative charge. Now remember, rubbing two different materials, they will acquire the same number of charge but different sign. So if this one is negative, then definitely the woolen cloth is gonna be positively charged. Question number 7. A neutral conducting sphere suspended by a thread is brought close to a negatively charged rod. What's going to happen is that the sphere will be attracted to the rod, because as we said, if it is neutral, it can be attracted to either a negatively charged or a positively charged object. Okay? Like it will always be attracted to the one it is introduced to first. Now, the last thing is kind of solving. The force between two equal charges 2 centimeters apart is 10 meter per Newton. If the distance between the charges is increased to 2.5 centimeters, then the force between them becomes. What you need to know is that the distance is always squared. So if 2 squared, pay attention, don't forget in the exam, squared, 2 squared centimeter became 2.5 squared centimeter, okay, then how much will 10 meter per Newton become? Okay, but actually, if you do it like this, you are gonna get it incorrect. So don't make it a relation. Why? Because the distance and the force are inversely proportional. So what you can do is flip it. What do you mean by flip it, Amanda? That instead of putting the 10 meter Newton here, or the 10 micronewton here, I don't know what it is, you put it on the opposite side. So now 10 micronewton, and then question mark. So if they are inversely proportional, always remember, force is inversely, excuse my spelling, inversely proportional to the distance squared. So that means if you're gonna make it in an equation like this, 2, the initial, so I'm gonna put distance squared 1 is gonna be here. However, distance squared 2 is gonna be here. Whereas force 1 is gonna be on the side of the distance squared 2, and force 2 is gonna be on the side of the distance squared 1. Now, if you want to understand it, it is like if you have two objects close to each other, okay? They will definitely have a closer force of attraction if they have a smaller distance between them. However, if they are farther apart, no matter, like, if let's say they are the same mass, to keep it relevant, they are the same mass and they are farther apart, okay, then the force of attraction is weaker. Take, for example, an astronaut on Earth. Okay, this is the astronaut on Earth. He is staying close to the Earth. He's not able to fly. He does not lose his gravity. However, when he goes out of space, his distance from Earth is farther away. So he will acquire, or he will not acquire, he will lose the sensation of gravity. So that ends off with 2 squared centimeters. So distance squared 1 will give us distance squared 2, okay? And then force 2 is gonna give us force 1, which is 10 micronewton. Then you do cross multiplication. That gives us 10 micronewton times 2 squared divided by 2.5 squared, and you are gonna get 6.4 as an answer. So an answer over here becomes 6.4 micronewton. So let us, or millinewton, I don't know what's that unit, but anyways, let us submit, and thank God we do not have any mistakes. And again, my condolences for Prithika, and I hope she rests in peace.